Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In this session, we are discussing this current sense circuit for IPM current monitoring. Here it is using SM1246MKF. In any circuit, when it is using this IPM, it can be used with 3 different shunt resistors connected to each emitter of low side IGBT. One resistor here, second resistor and third resistor. So the current flowing in each section will be monitored through shunt resistance, and its dropped voltage value will be transferred to the microcontroller, and same time these voltage will reach to its respective overcurrent protection control, that is for safety. If we see this, it will reach here at OCP, this one at this OCP pin, overcurrent protection. In second configuration that is used in this board, that all emitters are connected together and there is just only one shunt resistance, and this shunt resistance will be used to monitor the accumulated current for 3 phases, and its value will be transferred to microcontroller, and same time this value also will be provided to overcurrent protection pins, and all overcurrent protection pins are connected in parallel. If any time any one IGBT is drawing more current, any phase is overcurrent, all the IPM will turn off. If you see the circuit, here it is using R04F. R means 0.04 F, 4 milliohms shunt resistance, and it is using 4 resistors, 4 milliohm each. These are in parallel. One side is connected to ground, and ground of main DC capacitor power rail is reaching here, and the voltage dropped value that is connected to these emitters. This is outside of the shunt resistors. It is reaching to these shunt resistors are reaching to emitters of low side IGBTs that are here. And in the rear side, from the rear side, this signal, it is reaching to this point and it is passing to PCB second side. That are these two components, 200 ohm resistor, this point, then after resistor, this point, it is reaching to this point. Then from the output point, from here, this point, the final output signal, it will reach to microcontroller, this point. Here is 1 kilo ohm resistor, then this signal is reaching here, this is test point, and it is reaching to microcontroller pin number 7. Pin number 7. So amount of this current from this IC, its output pin is pin number 1, that is here. This is output pin, and this output from pin number 1 is reaching to microcontroller, this point. So this current level will be monitored all the time, so microcontroller will understand how much load is there. If there is any short circuit, if there is any overload condition, any malfunction, if this voltage value at pin number 7 will increase than the value that is mentioned in the software, it will generate IPM current error, that IPM is drawing more current. When we receive overcurrent error, sometimes the IPM is bad. If IPM, any IGBT is damaged, it will draw more current. In that case, This resistor will draw more voltage. These voltage will go to microcontroller. Sometimes this amplifier IC, that is most failure component in these boards, that is LMV358. It is here, LMV358. It is dual operational amplifier. Its pin 4 is ground, pin 8 is VCC. It is receiving voltage from this capacitor that is closer to this IC. If SMPS is bad, if a power supply is damaged, at that time this operational amplifier may damage. In some boards it is using LM324, LMV324 IC, that is 4-channel operational amplifier. If you are receiving current error, at that time we can check voltage at these two pins, pin number 8 and 4. If it is receiving 15 volt, 18 volt, that's good. When this power supply is turned on and standby power on signal is present, at that time it will provide 15 volt, and these 15 volt are provided to PFC controller, this capacitor, ACS 710 IC, and IPM. We can check here pin number 2. It is connected with this pin and with this pin. All overcurrent protection pins are connected together. It is also connected at this pin. When there is overcurrent and same time it is providing signal here, and this signal is also reaching to this point, first it will turn off the IPM, intelligent power module, and it will also intimate to microcontroller to generate error code. This voltage divider network, it is to provide inverting and non-inverting inputs. Then feedback circuit, that is between output pin and inverting input pin, pin number 2. Input signal, feedback signal, and here is output. This output from here, if you locate, it is coming out at this pin, and this line is reaching here, then this line is reaching here, then it is here. Interleaved shunt resistor, this signal which we tested from the second side of the board. I hope this video is informative. If it is good, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.